All right, I want to do a few more examples using the square root property, but these ones are going to be just a little bit more involved. Let's dive in. Let's solve x plus 3 squared equals 10. This is more involved than the previous problems. However, we still have something in the form something squared equals a constant, and so we can use the square root property here. When we take the square root of the left-hand side, we're left with just x plus 3, because taking the square root undoes the squaring. They cancel each other out. Then on the right, we take the square root, and because 10 isn't a perfect square, we write plus or minus square root of 10. Now, we have one more step that we need to do. We need to get x alone, and to do that, we need to subtract 3 from both sides. This leaves us with x alone on the left. Now, on the right, there's a very particular way that we will usually write these things. These two are not like terms. This one is a square root, and this one is an integer, no square root, so we can't combine them. And in general, whenever we have a term that has a plus or minus in front of it, we put that term at the end. So we're going to put the negative 3 out front, and then plus or minus root 10 afterwards. This is our final answer. X equals negative 3 plus or minus root 10. And what this actually means is that there are two different solutions. One is negative 3 plus the square root of 10, and the other is negative 3 minus the square root of 10. We could write these out with a comma in between if we were entering in our answer online, but if you're not doing it online, this is perfectly fine. This means two solutions, negative 3 plus 10 and negative 3 minus 10. Let's look at two more problems. Let's solve x plus 2 squared equals 9. Again, we have an equation in the form something squared equals a number, so we can use the square root property here. When we take the square root of the left-hand side, we're left with x plus 2, because taking the square root cancels out the squaring. Now on the right, when we take the square root, we end up with plus or minus 3. Because 9 is a perfect square, we can actually evaluate that square root, and we get plus or minus 3. Now again, we need to get x alone, so we're going to subtract 2 on both sides. And again, we're going to leave the plus or minus term at the end. So we're going to write this as negative 2 plus or minus 3. Now, I'm not going to leave it like this. This is not an acceptable final answer because these end up being like terms and they can be combined. But we have to do it in a specific way. Because one of the answers is negative 2 plus 3, and the other is negative 2 minus 3, we need to evaluate each of those individually. So we end up with x equals negative 2 plus 3, or x equals negative 2 minus 3, and then we can do each of those simple arithmetic problems. Negative 2 plus 3 is 1, and negative 2 minus 3 is negative 5, so we end up with x equals 1, or x equals negative 5. Let's look at one more. This time we're going to solve 2x plus 3 squared equals 16. Again, we have an equation in the form something squared equals a constant, so we can use the square root property. When we do that, we're left with 2x plus 3 on the left, and then on the right, plus or minus 4, because 4 is the square root of 16. Now again, we need to isolate the x. Here, we're going to subtract 3 from both sides. This leaves us with 2x equals negative 3 plus or minus 4. And then to get x alone, we have to divide both sides by 2. This gives us x equals negative 3 plus or minus 4 over 2. And just like the last problem, we're going to look at these two answers separately, because we can actually take negative 3 plus 4 over 2, and we can evaluate negative 3 minus 4 over 2. So when there are terms that can be combined, and we're able to actually evaluate these further, you do want to look at each of the solutions independently. This is different from the first example, where we didn't have like terms, so looking at them separately doesn't allow us to break anything down. Let's finish here. In the first one, negative 3 plus 4 is 1, so we end up with x equals 1/2. Or, in the second one, negative 3 minus 4 is negative 7, so our other solution is x equals negative 7/2.